Our third module is on symbolic logic. We have logic in all aspects of our lives, even though we may not see it. It occurs a lot in electronics, where we have logic circuits. If there's voltage to this lead, then light this bulb. If not, light that bulb. We also see it in computers, and computer language is broken down into true and false statements, zeros and ones. It goes beyond topics with a lot of math. We see it in medical fields, see it in diagnostic flowcharts, whether for a person or for a car repair. If the patient has a sore throat and a runny nose, then check for strep. If you run the diagnostic and your voltmeter is too low, check the alternator, that kind of thing. We're going to be looking specifically at symbolic logic in this module, where conditions will be represented with symbols. We'll start off with some vocabulary. In logic, words used to connect thoughts or phrases are called connectives. Standard connectives include and, or, and if-then. Now, the word or can be used in different ways. If you're buying a car and you're asked if you want the red one or the blue one, we're going to drive off with one or the other. We're not going to drive off with both of those cars. That's an exclusive or, meaning this or that, but not both. That's exclusive. On the other hand, when the waiter asks if you want an appetizer or a cocktail, he means you could order an appetizer, or you could order a cocktail, or you could order both. This is called an inclusive or. And we're going to be focusing on the inclusive or unless we say it otherwise. More vocabulary. A statement is a sentence that can be judged to be either true or false. We have two types of statements. We have simple statements, which convey one idea, and we'll have compound statements conveying two or more ideas. Assigning a truth value is labeling a statement as either true or false. We're going to see quantifiers. These are words like all, none or no, and some. We want to be careful when we're looking at the quantifiers, because a lot of people struggle with these when we're looking for the opposite meaning. This is called the negation of a statement, and we're going to run into negations quite a bit in this module. Let's look at the statement, bicycles have two wheels. I want to quantify this using those phrases that we had earlier, or words. One option would be to say that all bicycles have two wheels. And in this case, we see an example where all bicycles have two wheels. Another quantifier would be to say that some bicycles have two wheels. And we have a picture of some bicycles that don't have two wheels, and some that do. Another quantifier would be to say that some bicycles do not have two wheels. And again, we have some bicycles here that don't have two wheels. And finally, no bicycles have two wheels. And we see an example here where we've got a bunch of one-legged bicycles. Looking at the two middle statements, they may seem at first to convey the same idea. In both cases, we see some bicycles that have one wheel and some with two wheels. However, there's a slight difference in these two statements. When we say some bicycles have two wheels, we're not saying anything about any bikes that don't have two wheels. So for example, I could get rid of all my one-wheeled bicycles, and the statement, some bicycles have two wheels, is still true. All I need to know is that at least one bicycle somewhere in the world has two wheels. Similarly, on the second one, it says some bicycles do not have two wheels. It doesn't say anything about bikes that do have two wheels. So I could get rid of all of these bikes with two wheels, And as long as there's one bicycle somewhere in the world that doesn't have two wheels, that statement is true. The negation of an all statement, an all do statement, all bicycles do have two wheels, would be a some do not. Likewise, if you have a some do not statement, the negation would be that all do. Looking at our some bicycles do have two wheels, the negation of that would be to say that no, there aren't any bicycles anywhere that have two wheels. So the negation of some bicycles have two wheels would be no bicycles have two wheels. And conversely, no bicycles have two wheels has the negation of, well, if no bicycles have two wheels, then there has to be one somewhere that has two wheels. That's the negation of it. Negations can be kind of complicated. Basically, we're looking at all do versus some don't, or none do versus some do. Find the negation of all dogs have four legs. Well, if we can find one dog anywhere that doesn't have four legs, then we have found the negation. So to say some dogs don't have four legs, that would be the negation of all dogs do have four legs. Find the negation of some cats have antlers. Now these can be tricky because the sums can go either way. We need somehow to represent that there aren't any cats with antlers. We could say no cats have antlers, none do. Or we could say that all cats don't have antlers. What we're trying to get across is that there are not any cats with antlers anywhere. So whether you say it with all don't or none do, as long as something is negated there, we'll get across the idea that it's the negation of some cats have antlers. Find the negation of no mice can ride motorcycles. Now again, this statement could be thought of another way too. We could think of it as all mice cannot ride motorcycles. Now, these are two different ways of looking at the exact same idea. Either way, we don't have any mice on motorcycles. The negation of that would be to find one mouse somewhere who can ride a motorcycle. I believe his name is Ralph. Some mice can ride motorcycles. That would be the negation of no mice can ride motorcycles. Finally, find the negation of some wizards do not attend Hogwarts. Well, if some don't, the negation would be that all do. All wizards attend Hogwarts.